Here in this particular video, we are starting with the topic shading and how the shading can be done, and different categories we shall be discussing that one. So how do we color the whole surface? At first, the illumination model computes the color of some sample points. So regarding this one, we have done the previous videos to calculate the respective illumination model, which will compute the color of some sample point on the object surface. While doing the coloring, the entire object, it is done at the rasterization level. The procedure to color the entire surface is known as shading. So shading is nothing but a procedure which will put the color on the entire surface of the object. So shading is a technique for finding intensity profile of a surface as a whole to simulate its appearance under given lighting condition. So that is a very important one. So shading is nothing but one technique with the help of which we can find out the intensity profile of a surface as a whole to simulate the appearance under given lighting conditions. Such techniques call for implementation of illumination model at each visible point on the surface of the object defined by the polygon meshes. So here you will be finding some visible points on the surface of the object, and there we will be finding out their illumination model, and from there the technique or the procedure will be executed to get the coloring on the surface of the object using the technique known as shading. So there are different types of shading models. So first one we are considering as this one as flat shading or constant shading or faceted shading. So less computation will be needed for all these cases. Next one we are going for the interpolated shading. So the constant shading scheme is a kind of trade-off between the computational expense and the realistic shading quality. So in case of this is a constant shading, you can find this one as a constant shading. Here the computational complexity is very high. So if you go for more computational complexity, then you are going to get the realistic shading for the object. To yield more realistic shading with intensity varying from point to point on a surface needs due consideration to change of curvature, direction of incident light, and position of the viewpoint from one point on the surface to the another. So to have the realistic shading on the surface of the object, we should be considering the curvature which is available on the surface of the object, and also the respective direction of the incident light and position of the viewpoint from one point to another point, because the shading will vary accordingly. So here we are having another methods. So first one is the Gauss shading once per vertex, and another one is our Phong shading, so one per pixel, and thus requires heavy computations. So regarding this shading and different techniques and procedures we will be discussing in the next videos. Please watch all of them for the better understanding. And thanks for watching this.